Hi guys, welcome back. Here's our new lesson. We're going to talk about converting fractions to decimals. So we're moving away from integers and we're going to talk about making fractions into decimals and decimals into fractions. So take a look at this first example. It says use a picture, words, and a number to represent the quantity of 2 out of 3 in 3 different ways. So go ahead and pause the video. Fill in the 3 boxes, and I'm going to go over the answer and hopefully you get it right. Okay, here we go. All right, take a look at my answer here. I've got 2 circles filled out of 3, so there's my picture. In words, I have 2/3, and as a number, I wrote 2/3, 2 over 3, the fraction 2 out of 3. Okay, so hopefully you got that one right. All right, so talking about fractions, I have in our lesson 2 different kinds of decimals that you're going to come across. You have a repeating decimal and a terminating decimal. We're going to talk about the repeating decimal first. So we're going to look at this example, 2/9. Okay, and it turns out the answer is 0.2 repeating, and if you see there's a little green line above the 2, and that means it repeats or goes on and on without end. And I'm going to take a look and show you why that is. So we have 2/9, and if I change that over to a decimal, if you read this fraction, it's 2 divided by, remember that line means divided by, 9. So we put 2 in the house and 9 goes outside. 2 is divided by 9. Now 9 cannot go into 2, so we have to add a decimal point. Think back to 5th grade. You have to add a decimal point and a 0. And I'm going to put my little dashes up here. So we said 9 does not go into 2. We get 2 left over. Okay, you got to bring down your 0. 9 goes into 20 2 times, and I get 18, and I get 2 left over. So I have to continue my division. Bring down another 0, and it goes in 2 again, and I get 18. I hope you're seeing what's happening here. I'm getting a pattern, right? So I'm always going to end up with 18, and I'm always going to end up with 2 left over. And so if you continue to add zeros, you're going to continue to put 2's on the top and continue to get 2 left over. So we end up with what's called a repeating decimal, meaning it goes on and on forever with no end. So we stop the division once we find a pattern, and I've seen a couple different things. You can put dots to show that it's repeating and goes on, or most of the time you'll see this line that we put over the piece that repeats. Now it might be more than one number. In this case it's just the 2 that repeats, so we only put the line over the 2, not the 0. Okay, so that's how you change a fraction to a decimal. We divide. What I want you to remember is Taibo, T-I-B-O, and you might want to write this in your notes. Top, in, bottom, out. Top number goes in the house, the bottom number stays outside. So that might help you set up your division problem. Remember, it no longer means that the bigger number is on the inside and the smaller number's on the outside, especially when you work with fractions. So it could be either way. And take notice that this example, the smaller number is inside the house and the 9 is outside. Okay, so all right. Here's some examples of some repeating decimals. Notice that the line is over the 3 and the 6. So that would mean that this would be 3, 6, 3, 6, 3, 6. Both numbers have the line over them, so that means that the repeating numbers are 3 and 6 in that pattern. The repeating decimal here is 0.125, so that is going to repeat in that order: 125, 125, 125, and it would continue on like that forever. Now take a look at the third example. Notice the line is only over the 9, so that means the 9 is the only thing that would repeat on. The 1 would not, and the 4 would not. And the same thing with this last example. The 6 is the only number with the line over it, so that's the only thing that repeats. The purple box here are examples of numbers that do not repeat, and notice that the reason we can tell that is because there's no line here, there's no dots continuing us on. So these just have ended and there's no repeat. Okay? Alright, so there's just some more examples here of repeating versus not repeating. Notice that you could have a decimal with a whole number out in front, and this last example here, 54 is repeating, so it's 3.545454, like that. Okay? Alright, so now we have a couple examples. What I'd like you to do is to figure out the division, okay, for 1/9. Let's do that one. Top in, so 1 goes in, 9 goes out. We have to add a decimal and a 0. Remember to float your decimal point up. We just line it straight up. 9 goes into 10 once. We get 9 and 1 left over. We bring down another 0 and we're getting a pattern. So we're getting a 1 that repeats. So we got 0.1 repeating. If we take 2/9, 2 goes in, 9 stays out. Okay, add a decimal and a 0. It goes in twice, and we did this one already, and we get 0.2 repeating. If I take 3/9, I'm going to get 0.3 repeating. Do you see a pattern going on? I hope you do, because this family of ninths, the decimal equivalents have a pattern, and so do the 11ths. Let's take a look. There you go. So we have 0.1, 0.2, 0.3, 0.4, 0.5, and they all repeat. So the whole family of ninths repeats, okay? And they are multiples of 11, and then the 11ths are multiples of 9. If you take a look, we have 0.09 repeating, 0.18 repeating, 0.27 repeating. So it's kind of something to keep in mind when you're looking at the ninths and the 11ths, that they do follow a pattern. Okay, so if you want to stop the video now and go ahead and try this one, I want you to take 7/15 and change it to a decimal. Remember Tae-Bo, top in, bottom out, and give it a shot. Okay, I'm going to go over the answer. I hope you get it right. Remember 7 and then 15. And let's take a look at the next slide. And the 6 is repeating. So 15 goes into 74 times, and then we bring down a 0. It goes in 6 times, and the 6 keeps repeating. We get the same remainder over and over again. Okay. Alright, if you have a mixed number, the decimal version of that mixed number, the whole number, take a look. 2 1/3. 2 is our whole number, and look at the decimal equivalent. The 2 is out in front. So it doesn't matter whether you have a mixed number or the decimal version of that, the whole number will still be out in front. The fraction part will then become the decimal part of that fraction. So if we take a look at 1/3, if we divide out 1/3, this is where the 0.33 repeating is coming from, the 1/3. Okay, and it just shows that the pictures are the same here for both. Okay, try this one. I want to know if the airplane can fit through the tunnel. Stop the video, figure out if you can convert 7/12 of the airplane, the 8. Notice there's an 8 here, there's an 8 here, so we need to convert 7/12 to see if 7/12 is going to be smaller than 0.7 here to fit through the tunnel. So go ahead and give that a shot, and I'll give you the answer right now. And here you go. There's the division, 7 in, 12 out, and we convert the fractional part to the decimal, and it's just going to make it. We've got 0.583 and the tunnel is 8.7. So the jet plane will fit through the tunnel. It is slightly smaller. It's just going to make it. Okay. I'm going to stop the first video right there, and we're going to talk about terminating decimals when I come back. Alright, so that'll be on part 2. Thanks, guys.